Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to find out how to calculate the standard deviation from a table. So I've used this, I have a table or frequency distribution when we calculated the mean from a frequency distribution. And so we're going to use that. So if you need to copy that again, maybe pause the video, copy that down, and then let's do that. That's our goal today. We're going to calculate the standard deviation from a table. And you could write a frequency distribution if you wanted. I'm using those words interchangeably. Well, remember, once we have a table of data, within one of the classes, the data is hidden now. So between the 0.5 and 2.5 in that first class, it says we have a frequency of 4. There could be 4 1s, there could be 4 2s, or there could be a combination of 1s and 2s. We don't know. So what we do is we use the midpoint to represent the data values in the first class. So remember, let's just review here. We calculated the midpoint by taking the lower boundary, 0.5. We added 2.5, the upper boundary, and divided that by 2. 0.5 plus 2.5, that is 3, divided by 2, and we got the 1.5. And we did that for each one of those, and that's how we calculated those midpoints. And I would encourage you to take a moment and double check the values that we have here. So let's calculate our standard deviation. Let's calculate the standard deviation. So this will definitely be s squared, a sample, because there's no way to have all possible digits from pi. So remember that s squared, the variant, we'll first calculate the variance and then take the square root to get the standard deviation. So starting with the variance, that's s squared. This is sample variance. It's the sum of the data minus, the data minus the mean of the data. We square that, and then we divide it by the number of data minus 1. Okay, and in our last video, we already found that our sample mean was 5. This is going to work out really nice. Here we go. So we take our first data value. Well, that is 1.5. We subtract the mean, that's 5, and we square it. Now, we have to do that for the next 1.5 because there's 4 1.5s in the first class. So we could write plus 1.5 minus 5 squared plus 1.5 minus 5 squared plus 1.5 minus 5 squared plus. And then we could do that for the next data values and keep going. But an easier way to do that would be to do it, and then we'd divide that all by 20 minus 1. But instead what I'm going to do is, notice that this is just being multiplied 4 times. So let's write this as 1.5 minus 5 squared times 4, the frequency. That's what this 4 is. This 4 here is this 4 here. And now we can repeat this process. So our next data value is a 6. So we go plus, or it is not 6, that's the frequency. It's 3.5. We subtract the mean of 5. We square it and we multiply it by its frequency of 6 plus. I'm having a camera issue here. Okay. Then we go to the next data value. That's 5.5. 5.5. Subtract 6. Square it. And we have to remember that this happens 4 times. Plus 7.5 minus the mean, which is 5, squared, and that happens 3 times, plus 9.5, the next data value, minus 5, squared, but that happens 3 times. So we're going to take all of that, divided by our number of data, that's 20 minus 1. I'm going to bring my calculation over here. And let's see, so 1.5 minus 5, that's 3.5. Square it, you get 12.25. 12.25 times 4 plus 3.5 minus 5 is 1.5. Square it to get 2.25 times 6 plus 5.5 minus 6, that's 0.5. Square it, 0.25 multiplied by 4 plus 7.5 minus 5, that's 2.5. We square it, we get 6.25 times 3 plus. The last one is 9.5, subtract 5, that's 4.5. Square it, that's 20.25. Multiply it by 3. Divide all that by 19. So at this point, if you want to put this in a calculator, you don't have to do these in your head. I do them just so you can see how the arithmetic works. I think it's always a good exercise. But I'll try to do this in my head for the rest of them, as you should, and you can do so with me, or put it into a calculator to double check me. Either way, either route is wise. So 12 times 4, that's 48, and 1 more, that's 49. Plus, let's see. 8, 9, 13.5. I don't know if I did that right or not, but we'll find out. Plus 4 times a quarter, that's just 1. Plus 3 times 6.25, that's 18.75. Plus 3 times 20, that's 60.75. Take all of that, divided by 19. At this point, I'm going to go to the calculator. It's getting a little rough. 78, 79.5, 80.5, 84, 124, 133 divided by 19. I think that's it, but I'm going to check myself. 49 plus 13.5. 49 plus 13.5 plus 1 plus 18.75 plus 60.75. Oh, 143. Huh. Oops. That's why we check. Okay, let's fix that. Fix that problem. 143 divided by 19. Let's check that on our calculators as well. 143 divided by 19. I come up with 7.5263. So there we go. I'm going to do it. It's approximately 7.5. Now, at this point, if you wanted the variance, then we would stop at 7.5. However, did I round that correctly? 7.52. Yeah. However, we wanted the standard deviation. So to get the most accurate one, do not round the variance. Instead, what you do is you take, to get S, remember S is the square root of S squared. So in other words, if we take the square root of this number, we'll get the best we can, 143 divided by 19. So here we go. So let's do that on our calculator. Take the square root, which is this, you go second, and then you hit the x squared button down below. We want 143 divided by 19, and now you can press enter. 2.743. Remember, our data is in whole numbers, so we're going to stop at tenths, 2.7. So we say approximately, or you can just say equal 2.7. And that is how you find the standard deviation and the variance from a frequency distribution or from a table. Or if this was in its graphical form, it would be a histogram. I hope that helps, and thanks for watching.